Our goal in this lesson is to find the number of real roots of a quadratic function and their location. However, in order to be able to do this, there are certain skills that we need to have um, to be able to do that. So the skills needed to be able to find the roots of the number of real roots of a quadratic function and their location is to first make sure that we know how to factor. Okay, that we know how to factor different forms of quadratic expressions. And so what we're going to do here is we're going to look at different forms of quadratic equations or quadratic expressions, and then factor them so that you can become familiar with the different ways to factor depending on what the expression looks like. Okay, so let me start right away here. For example, if we have a quadratic expression that is x squared plus some number b times x plus some number where this is positive and these are all positive, right? Then we say that we're going to factor by addition of factors. So the way that we do this is we look for the factors of 10. We look for the factors of 10 and say the factors of 10 are 10 times 1 and 5 times 2. And then we say, since this is an addition sign, we say, what are the factors of 10 that added give me a positive 7? So the factors of 10 that added give me a positive 7 clearly is not 10 times 1 because 10 plus 1 is 11. But 5 plus 2 gives me a 7. And because we want this to be a positive 7, we want both of these to be positive numbers. So here are the factors of 10 that added give me a positive 7. Okay, so with that, you go ahead and you break up x squared plus 7x plus 10, break it up into two factors like this. And in the first factor, you put your factor of x here and here. And then in these two spaces, you put your plus 5 and your plus 2. Okay, and this is equal to this, but this is now in factored form. So again, let's look at what we did. Okay, we looked at this number, we found its factors 10 times 1 and 5 times 2, and then we say that because that's a plus sign, we need to be able to add the factors to give me a positive 7. So these are the numbers that add up to 7, but in order for them to be positive 7, they must both be positive, right? And then once I know that, then I can rearrange this in this way. So both of these expressions are equal. This is an expression, quadratic expression, but it is not in factored form, and this is in factored form. Okay? So notice something that you should notice here is that whenever this sign is positive, both of these signs will be the same sign, and that sign will depend on this sign. So these positive signs depend on this one, not this one. This sign only tells you that you're going to add, but the signs that go here depend on this sign. So in this case, because it's a positive sign, then it'll be two positives here. Okay, but if it was a negative sign here, they would both be negatives. Okay, something else that I'd like you to look at here is that notice that positive 5 and positive 2, if you add them, you get positive 7, but if you multiply them, you still get a positive 10. Okay, so that's our first example. Let's look at another example where you still have a plus sign here, but now you have a negative here, right? So this is still done by addition, right? I said here by subtraction of factors, but in fact it's not subtraction of factors, it's addition. And how do we know that it's by addition of factors? Because this is a plus sign. This sign tells you the operation, so it's going to be done by addition. And here what we want to do is we want to find all the factors of 24 that added will give me a negative 11. So I can start with 24 times 1, 12 times 2, because these are all the factors of 24, then 8 times 3, then 4 times 6, right? Those are all the different factor pairs of 24. And so now the ones that are going to be, the ones that can be added to, the ones that can be added to give you 11 are these two. But we're looking for a negative 11, so they both need to be negative. So negative 11, negative 8 plus negative 3 will give me a negative 11. So then this expression here, you can rewrite it as x times x here, and then minus 8, and then minus 3. And this is the factored form of this, right? This is like a sum of terms, but this is a multiplication of two terms, right? And again, notice that because this is a plus sign, we're doing things by addition, but the numbers that are added should give me a negative 11. So these are the factors of 24. The ones that add up to 11 are 8 and 3, but they need to add to a negative 11, so both signs must be negative to add up to a negative 11. So negative 8 plus negative 3 give me a negative 11, but if you multiply them, a negative 8 times a negative 3 still gives me a positive 24, which makes sense. Okay? Now sometimes there's a number in front of the x squared here. See that? In the previous two problems, there's only a 1 that we don't write down, but in this case now you have a number in front of the x squared. We have 6x squared plus 17x plus 12. So the way we do this is a little bit differently. It's similar to this one, but it has an extra step. So now what we're going to do is we're going to take the factors of 12, which we know are 12 times 1, 6 times 2, and then we have 3 times 4, right? On this side, we have 6 times 1, and then 2 times 3. So the difference here now is that we need to combine a pair of values here by multiplication to a pair of numbers here, and then add them up to give us a 17 positive, right? So for example here, if I multiply 6 times 12, that's going to give me a 72. If I multiply 1 by 1, it's going to be 1. So 72 plus 1 is 73. That's too high because we want to get a 17. What if we reverse the order? What if we say 6 times 1 plus 12 times 1? That gives you 12 plus 6, which is 18, which is too much. So these two will not go together well. They don't produce the values that we want. Let's try this. If you multiply these two, you get 36, and then 1 times 2 is 2, so 36 plus 2 is 38. That doesn't give us a 17. What if we switch them around? What if we say instead 6 times 2 is 12, and then 1 times 6 is 6, and 12 plus 6 is 18, it's not 17. So the combinations here don't work. How about here? 6 times 3 is 18, and then 1 times 4 is 4, so 18 plus 4 is 22. That doesn't give me 17. Let's switch the order. 6 times 4 and then 1 times 3. So 6 times 4 is 24. 1 times 3 is 3 added gives us 27. So that's not going to give us a 17. So this pair of numbers does not work with any of these. So now we're going to try this one. So let's go with this. 24 plus 3, that's 27. It doesn't give us 17. What if we switch them around? 3 times 12 is 36 plus 2 is 38, so that doesn't work. So this pair does not work with that. How about here? 2 times 6 is 12, and then 3 times 2 is 6, and 12 plus 6 is 18. It's too high. How about if we switch them? How about 3 times 6 is 18, and then 2 times 2 is 4. So 18 plus 4 is 22. That doesn't work, so these don't work. Okay? How about here? 2 times 3 is 6, and then 3 times 4 is 12, and 12 and 6 is 18. That doesn't work. Let's switch it around. What about 2 times 4 is 8, and then 3 times 3 is 9, and 8 plus 9 is 17. These two are going to work, right? But the way that they worked was when we multiply 2 times 4 to give us 12, and then 3 times 3 to give us 9, right? So that gives us 8 and then 9, and added together gives us 17. So since this is going to work, this is how we're going to write it down. You need to pay attention to the order of these things. We're going to take our 2 and a 3 and go 2x plus 3x, because there's an x squared that goes with those. Now, we know that we're trying to get a positive 17, so that means that these two have to be plus signs, because we're trying to get a positive number here. And then the numbers that you multiply together cannot be in the same group. Since you multiply 2 by 4, then 4 cannot be here because you're multiplying 2 times 4, so they cannot be in the same group. That means that 4 must go over here, and so this remaining 3 must go right here. And this is how we factored 6x squared plus 17x plus 12, right? So very quickly again, what did we do? We found the factors of 12, which are 12 times 1, 6 times 2, and 3 times 4. And then we found the factors of 6, which are 6 times 1, and then 2 times 3. And then we tried to multiply combinations of these numbers, and then add those combinations until they give us a 17. Positive 17, right? We realized that 2 times 3 and 3 times 4 give us those combinations. Give us that 17. If we say 2 times 4 is 12, 2 times 4 is 8, right? And then 3 times 3 is 9. So we get 8 plus 9 added, because that's the addition symbol, is going to add it should give us 17. Now, because we're trying to get a positive 17, both of these signs have to be positives, right? Remember, whenever these are positives, a plus sign, an addition sign, these two signs must be the same sign, and that sign will depend on whatever this sign is, right? So if this is positive, this will both be positive, or if this is negative, then this will both be negative. Okay? Let's look at another example, but this time, look at this. It's still by addition, but we're trying to get a negative 23. So for this problem, let's again write the factors of 10, which we know are 10 times 1 and 5 times 2. And then here we're going to have 12 times 1, and then 6 times 2, and then 4 times 3, right? And now we got to play around with these so that we can multiply combinations and then add to get 23. So let's see if we can do this, okay? Let's see if we can do this a little bit fast. So look at this. If I say 12 times 10, that's 120, and then that's 1 times 1 is 1. 120 plus 1 is not going to give us 23. So let's change the arrangement. Instead of saying 12 times 10, now let's do 12 times 1, which is 12. 10 times 1 is 10, and then 12 plus 10 is 22. So it's 1 short of that. Let's try this again with this one. So 12 times 5 is 60, 1 times 2 is 2, added is 62. That's too much, that's not 23. Now try a different combination. 12 times 2 is 12, 1 times 5 is 5, 12 times 2 is 24, 1 times 5 is 5, 24 plus 5 is 29, that's too high. So this did not work with any of these. So this is out. Now this one. That's going to give us 60 plus 2, that's too much. So reverse it. 20 plus 6. So I'm multiplying in my head. I'm going 20 plus 6, right? And that's going to give us 26. That's not going to work. So that's not going to work any way we do this, because that's going to give us 60 plus 2 is 62, or it's going to give us 6 plus 20 is 26. In either case, they don't work. So let's go here and here, okay? So this is going to be 30 plus 4 is 34. That won't work. Let's reverse the order. What about 12 plus 10? 12 plus 10 is 22. That's too short. So this is not going to work with any of these combinations. Let's try this one. That's going to be 40 plus 3 is 43. That's too much. Let's switch it around. That's 30 plus 4 is 34, so that won't work either. So these one won't work with that. Now here we have this. We have 20 plus 6 is 26. That's not going to work. What about the other way? What about 15 plus 8? 15 plus 8, that's 23, so that's going to work. So 15, that means that we're going to multiply 3 times 5 and 4 times 2. Notice how I'm grouping them differently so I know exactly which numbers I multiplied together. So now here I'm just going to say that this is going to be 4x and 3x. Now because we're doing things by addition and we want to get negatives, we want to make these both negatives. And then since I multiplied 4 times 2, the 2 cannot go here because the 4 and the 2 cannot go together. If you multiply the numbers together, they need to be in different groups. Since 4x is here, then the 2 must be on this side, and so the 5 will be on this side. Okay? And so that is how we multiply, and that's how we factor 12x squared is equal to 23x plus 10. It's very important that I point out and that you remember that this expression has exactly the same value as this expression. Okay? They're just two different ways of looking at the same thing. This is a sum, while this is a product. A sum is where you're adding or subtracting terms, but a product is where you're multiplying one group by another group, right? A binomial by another binomial. If you work this out, it'll give you this back. Okay? I suppose I could try doing that just so that you could see. If I multiply this times this, that's going to give me a 12x squared. If I multiply this times that, that's going to be 4x minus 2 is going to give me a negative 8x. Now if I multiply this negative 5 by 3x, it's going to give me a negative 15x, right? And if I multiply this negative 5 by this negative 2, it's going to give me a plus 10, right? Now here 12x squared does not have a like term, so it's just 12x squared. And then a negative 8x and a negative 15x, they add up to another negative, which is negative 23x. And then plus 10. And so you notice that if I multiply these two binomials, I end up with the initial quadratic expression. Okay? So in these first problems that we did here, we're doing everything by addition. Okay? That means when this is a positive sign. That's what we do when we're doing factoring by addition of terms. Right? Now let's go back here, continue here, and see what we do when we factor by subtracting factors. It's very similar. Okay, so let me put you through this one here. You have x squared plus 2x minus 35. So the first thing I want to do here is I want to find the factors of 35. So 35 times 1, and then 7 times 5. And those are all the factors of 35. Now I want to know which of these I can subtract, because see the operation is subtraction now. We want to know which of these pairs I can subtract to get a positive 2. So to get a 2 I must subtract these, right? But if I want to get a positive 2, then the largest number has to be positive, because I want to get a plus sign. So the 7 should be positive and the 5 must be a negative. That way I can get a positive 2. So here you go to your x squared and then just write x times x here. And then this is going to be a positive 7. And this is going to be a minus 2. Alright? Now something to point out here is that notice that whenever you're doing your factoring by subtraction, these two signs are never the same. They're always different. Because by having different signs, it's going to force you to subtract. You see that? Whereas in this other case, whenever this is addition, the signs are always the same sign, because if the signs are always the same sign, you have to do things by addition. So here, when it's a subtraction sign, the signs have to be different, and that's going to cause you to do a subtraction. And see, this is exactly the same as x squared plus 2x minus 35. And again, if I was to do what I did down here at the bottom, and if I was to multiply these together, you could see that this factor form, that the product of this times this will give you that. And let me do it really quickly so you could see. X times x is x squared. Then multiply x times this negative 2, and that's going to give you a negative 2x. So you multiply this term times both of these terms here. Now you're going to multiply the positive 7 times both elements in this group. So positive 7 times x is a positive 7x. And then positive 7 times negative 2 is a negative. Actually, I made an error here. This is a 5, right? That's a 5. I'm glad I caught it. So it was, let me take you back. X times x is x squared. X times negative 5 is negative 5x. Then this one, 7 times x is positive 7x. And then positive 7 times negative 5 is a negative 35, right? And then if you look at this expression, x squared has no like term. But negative 5x and positive 7x, they cancel out, leaving you with a positive 2x. And then a minus 35 because 35 doesn't have a like term. So notice that this factored form is the same as this sum form. They're the same because that's what we started with. So I did that just so that you could see that these two expressions are exactly the same thing. Okay, let's move on to example 6. Again, we're doing things by subtraction, right? We want the factors. Now in this case, we wanted to have a positive 2, so we wanted to make sure that our largest factor was a positive number, so that after the subtraction my answer would still be positive. In this case, we want to subtract the factors of 42 to give us a negative 11. So we want to make sure that we get a negative 11 by assigning the signs correctly. So let's look at the factors of 42. Now the factors of 42 are, let's see, 42 times 1, 24 times 2, I believe, let's see, 14 times 3, and then 7 times 6. All of those give you a 42. Now the ones that subtracted give you an 11. These don't give you 11. These don't give you 11. These, if you subtract, will give you 11. But we want to get a negative number. So we want the largest number to be a negative and the smallest number to be a positive. Right? So now we can go ahead here and create our factors. And because of that x squared, I'll put an x here and an x here. Now I can put my negative 14 here and my positive 3 right here. And so x minus 14 is the same x minus 14 times x plus 3 is exactly the same thing as x squared minus 11x minus 42. Okay? And I'm not going to multiply to get this again because I've already given you 2 examples of that, but what I will do is when I give you an assignment, I will ask you to multiply here using the FOIL method so that you can show that this gives you that again. Okay? Okay, let's go to example 7. Example 7 says, again, we're factoring by subtraction, but now we have a positive 3 here, but we also have a number on this side, right? So we want to make sure that we figure out how to do this. Okay, let me focus this. I think that's good right there. So again, we need to look for the factors of 18. So let's write them down now. We know that this is going to be 18 times 1, and then 9 times 2, and then 6 times 3. Those are going to be our factors for 18, right? Now for 10, we're going to have 10 times 1 and 5 times 2. And we need to combine, make combinations by multiplication with a pair from here with a pair from here until we can make combinations, then subtract and get a positive 3, right? So let's see here. Well, we know that 18 times 10 is 180 plus 1. 180 minus 1 is not going to give me a 3, right? How about if we reverse it? How about if we say 10 times 1 and 18 times 1, and then 18 minus 10 is 8, it's not a 3. So these two don't work well for this. They don't give us the 3 that we want. So we'll go now with these two. That's going to be 90 minus 2. It's going to be 88. That won't work. What if we reverse it? 9 and 20. 9 minus 20. I'm sorry, let me say that again. 9 and 20. And 20 minus 9 is not 3, right? That's 11, so that doesn't work. So how about so neither way works. So let's try these. 60 minus 3 is not going to work. Let's reverse it. How about 30 minus 6? That still won't give us a 3. So this did not work with any of these. So let's try this now. So 5 times 18 is 90. 90 minus 2, that's not going to work. How about if we reverse it? How about 36 minus 10? That won't work. 36 minus 10 is 26, so that's not going to work. So this is not going to work. Now let's try this one. 45 minus 4 doesn't give me a 3. How about if we reverse it? 18 and 10. 18 minus 10 is 8. It doesn't work. So that's not going to work. So how about these now? So now we have 30 and 6. So 30 minus 6 is 24. That won't work. So let's try the other one. 15 and 12. 15 minus 12 is 3. Alright, so it's 15 and then this goes with this. Now 15 minus 12, we want the 15 to be positive. We want, because 15 is the largest number, we want it to be positive. That means that we want this 3 to be positive, so that positive 15, and then the 6 to be negative, so that positive 15 minus 12 will give you the positive 3. See that? So you gotta be, just be careful with how you arrange the signs, right? Now you take your 5 and your 2, and because it has an x squared, you say 5x, 2x. Now because I multiply 5 by 3, they cannot be in the same group. So that means that plus 3 must be on this side, and the minus 6 must go on this side. Okay? And that's how you do that. Alright? If you want to play the video back, rewind it to go over the problem again, you definitely can do that. But let me give you another example, example 8 here, okay? So it's the same idea, okay? But now we want to combine the factors of 15 with the factors of 12 to subtract to get a negative 11, right? That means that we want the product of our largest number to be negative, so once we cancel the negative and the positive, we still get a negative 11. So let's see here. 12 is going to be 12 times 1, 6 times 2, and 3 times 4. Well, 15 is going to be 15 times 1, and then 3 times 5. So what I'm going to do again is the same thing I did before, is I'm going to multiply in my head and then subtract, okay? Now, I know that 12 times 15, whatever that is, it's a very large number, right? And then 1 times 1 is 1. So whatever that large number is, minus 1 is not going to give me an 11. It's too big, right? So what if I reverse these? What about, what's 15 and 12? 1 times, sorry, it's 15 and 12. 15 minus 12 is 3. It's not 11. We're trying to look for an 11. So these two don't work. Let's try these. That's going to be 36 and 5. 36 minus 5 is 31. That's not 11. Let's switch. Now 5 times 12 is 60 minus 3. That's 57. That doesn't give me 11. So this one doesn't work with any of these. Let's try this one. Now 6 times 15 is going to be what is it? 0, 3, 90 is 90, and then 90 minus 2 is not going to give me 11. So let's switch it. What about 30 minus 1? What about 30 minus 6? 30 minus 6 does not give me 11. So anyway, any combinations that I can create and then subtract do not give me 11. So these two don't work. How about these? 18 and 10. 18 minus 10 is 8. How about if we switch? 30 minus 6. 30 minus 6 is 24, so it doesn't work. So this one didn't work with any of these. So let's go here with 3 times 4. That's going to be 45 minus 4, 41. That doesn't work. What if we reverse it? 60 minus 3, that's 57. Doesn't give me 11. So no combinations here will work. So this will not work with that. Now here, 9 and 20. 20 minus 9 is 11. So that's going to work. So, okay, but let's see. 20 minus 9, so this is 20. These are going to give us 20, which is the largest number, 20. And then this is going to be the smaller number, 9, right? These two together. But listen, we want a negative here, right? So we need to make this 5 a negative and this 3 a positive, because that's going to give me a negative 20 plus 9 gives me negative 11, right? So I worked out my signs pretty nicely, and now I'm just going to put everything in order. 3x and 4x with that x squared will give me a 3x and 4x. And now we need, because I multiplied the 3 by the 3, they cannot go together. So since this 3 goes here, the plus 3 must go on this side. And so the minus 5 must go right here. Okay? And so that's I don't want to get a glare on this. There you go. So that's how you do it. Okay? So in this lesson, we learned how to factor by addition and how to factor by subtraction. Okay? All right. Good luck with the work.